Okay, so this is the sixth session for operations management, and in this session we are looking at the core issue of capacity in operations. So the questions which I'm asking you to think about for this particular session are: what do we mean by capacity management? What is it? How are demand and capacity measured? What are the alternative ways of coping with demand fluctuation? How can operations plan their capacity levels, and how can queuing theory be used to plan capacity? Okay, so you can see from this that demand and capacity are very closely related, and this is something which I'd like you to concentrate on. Demand looms as a very important issue in both this session and the next session when I start talking about inventory. Okay, so there's the transformation model. Looking at the deliver section still. So these 5 areas here are all part of what we would regard as delivery, and this is the section we're into now. So we've looked at direction, the strategy of the organisation, we've looked at design, how the organisation, the layout, the nature of the operation, how it can be set up. Now we're into what I often refer to as the nuts and bolts, the core aspects of operations management. Today this session we're looking at capacity. In the next session we'll be looking at inventory and lean synchronization together, and those 3 are very closely related or integrated via planning control, which relates capacity and inventory and to some extent lean synchronization to demand. So planning control is all about relating these issues to demand, which I'll come on to in a bit later. Okay, so straight in on planning and control. What we have is 2 sides of the divide. On the one side we have supply of products and services from an organisation, and on the other side we have demand for those products and services. Supply is limited by the operations resources. So this could be facilities, it could be capabilities, it could be machinery, it could be all sorts of things. Information available, skills. So the capabilities are the resources which the operation uses to deliver products and services. Okay, so based on these resources, the organisation can make plans which are formal statements for future activity. So the organisation side of things is about planning for the future. Okay, demand is determined by whatever the customers want. So demand fluctuates, and the customers will decide whether they want products from your organisation or from another organisation, services from your organisation or another organisation. So, and demand can be either from other organisations, other businesses. So your customers might be other organisations, and actually, as a matter of fact, that is what most organisations supply to services and products to other organisations, or it could be consumers. So control is the process of coping with changes in demand. So we have 2 sides of this then. We have plans for statements for the future on the one hand, and control in coping with changes. And operations managers are seeking continuously to reconcile both supply and demand. So they are seeking to reconcile plans and controlling demand. Okay? So the key concept I've tried to get us across here, so we have capacity on the one hand and demand on the other hand. And these can be understood in terms of a forecast. So the forecast is the way organisations normally, not always, but often seek to manage the relationship between capacity and demand. Capacity, what the organisation can supply; demand, what the customers, the consumers want; and forecasting is about what is demanded and how that will influence what we can supply. So it's trying to relate these 2 and reconcile the 2. Key problems are that too little capacity means we have delays on the one hand. So if you have too little capacity, you can only produce a certain amount of product or deliver a certain number of services in any given period of time, and customers will have to wait for the products or services. That's a delay, or they will seek to find replacements elsewhere from other organisations, and that is possible lost sales. Too much capacity means we have additional costs because we have facilities and capabilities, resources which are being unused. So what do we mean by capacity? Capacity is the maximum level of activity over a period of time for an operation under normal operating conditions. That means that an activity, an organisation can carry out production of something or supply some kind of service over a period of time. That's the key thing. So for example, a lecture theatre, the capacity of a lecture theatre is not the actual space or the number of seats in the room. It is the number of seats in the room over a given period of time. That may be an hour or a day or a week or a month or a year. It doesn't matter. But what we're looking at is how much activity can be delivered over a period of time. That's the key thing. That's why I say it's dynamic, not static. Okay, so in terms of our production and our demand, what we try to do is match capacity to demand via the forecast. I'll talk about forecasting in the next session. And this is sometimes called aggregating capacity to demand. Some of the key tasks which are involved in capacity planning. These are loading, which is determining what volume of production and activity can cope with. We have two different types, finite loading and infinite loading. Finite loading means that an organisation can reach a certain production level and not exceed it. So this is often used in production of products and delivery of products. So a factory can produce at maximum rate a certain number of cars or a certain number of whatever product that it's making, and it can't exceed that number. It can produce fewer than those, that number, but it can't exceed that number. That's a finite load. And that obviously is over a period of time, over a given period of time. Infinite loading means that the operation just copes with ever increasing demand. So an example, this is often found in services where the response to increasing demand is for queues to develop. I'll come on to queues towards the end of this session. Okay, so this is commonly found in service situations where rather than turn customers away, they're just allowed to form queues and dealt with as quickly as possible by the staff who are available to deal with them. Okay, another key task is sequencing. What happens first and what happens next? Okay, this is very important in operations which are project in nature or batch or functional in nature. Less important for line production or mass production, where the sequencing is determined prior to the actual production. Sequence is determined and then fixed into the facilities which are used to deliver the product or service. Scheduling is about timing. What happens first, what starts, and when it finishes, and then the next task, when that starts and when that finishes. And this can be modified or changed to meet whatever demand conditions happen to be prevailing. Okay, and I've mentioned the Gantt chart, which is commonly used in project management. So if you do the project management module next term, then I will discuss Gantt charts in more detail. Or Johnson's rule, which is another formula for thinking about start and finish times and adjusting these to suit different demand conditions. The key question here is, should capacity lead or follow demand? And we'll think about this when I get on to what we mean by demand and the nature of demand conditions. Okay, so what are the objectives of planning and control? These are to think about demand and the relationship between capacity and demand. So, easiest way to understand this is to use a chart which illustrates demand curves and capacity. So on the x-axis we have time, so capacity is understood as a amount of production over a period of time, and on the y-axis we have the amount of production. There is an estimate of current capacity. This is how much we can produce in any given time period. Okay, this is a flat line, so it's a finite loading situation. We can't produce more than this, we can deliver that much or less than that much. And then here we have a forecast demand curve. You can see at some points it's below the estimate of capacity, and other points it's above the estimate of current capacity. The way essentially most organisations work who produce products is to build up inventory or stock when capacity exceeds demand, and then use that accumulated stock to supplement the production when demand is above capacity. So that's fine in most production situations. There's a key problem with services in that services can't normally be stored. It can be. I mean, this exercise I'm going through now, of recording this session, is a way of storing a service. But most services aren't stored and are produced and consumed simultaneously. Therefore, it's difficult to build up inventory or stock which can then be used when demand increases. So this is why, as I said earlier, services frequently are loaded infinitely, whereas production is loaded finitely. Okay, so what we do in this situation is measure aggregate capacity and demand. What is the capacity of the operation? What is the demand of the operation? And how are these aggregated? And then we seek to identify alternative plans for our capacity. Do we stay at the current level? Do we change our capacity plan in some way? If we do, how and what do we do? So what we're seeking to do in the operation is choose the most appropriate capacity plan for our demand, given the nature of the operation we have. So I mentioned at the beginning that measurement is important, and measurement was particularly in the delivery of operations, so specifically inventory and capacity. Measurement is crucial. What we're doing is trying to understand where we are in terms of how much capacity we're producing, where demand is, and how much stock we have or how much inventory we have. So capacity measurement and demand measurement are absolutely vital to operations management. Without it, you have no real idea of what your demand will be and what your capacity is. Okay, so here's an example. We start with imagine a machine or a piece of equipment which can produce a certain number of widgets or products of any kind over a given period of time. Let's say it's a week. Let's say that machine can operate for 168 hours per week in theory. That's what we would call the design capacity. So the machine is designed to operate for 168 hours per week. This might be the same in a service situation. It could be a server in a shop or in a call center or something, and in theory that person could work for a certain period of time per week. Now, most operations have some planned loss. So planned loss for a machine might be changeover times, maintenance periods, times when it's not working for other reasons, and similarly with a person working in a service operation, that might be comfort breaks, coffee breaks, training time, those sort of things. Okay, so in this situation, the 168 hours in theory is what the operation could deliver work for. In actual fact, after you take planned losses away, what we call the effective capacity as opposed to the design capacity is 168 less 59, which in this example is 109 hours. Okay, now many operations end up with avoidable loss, which is where things go wrong. So a machine produces products or items, and for some reason these aren't produced to the right standard and rework's required, or somebody working in a service operation might make mistakes in their service or might need to check things, and those would be lost production. So that's what we call avoidable loss. If all things were perfect, in a perfect condition, there would be no avoidable loss. The loss would be avoided. So in this particular example, we have 109 hours of effective capacity. We've, in this particular example, got 58 hours of avoidable loss. That leaves us 51 hours of actual output per week. Okay, so you can see there's three different measures there: design capacity, effective capacity, and actual output. Now we use two words: utilization and efficiency. Utilization is the function of actual output divided by design capacity, and efficiency, how efficiently we're using our capacity, is actual output divided by effective capacity. So there we are. We have two measures and two words, efficiency and utilization, which have very specific meanings in operations management. Another measure frequently used in manufacturing, in factories, is what we call overall equipment effectiveness. This has a number of different measures in it. We start with what's called a loading time. This is like design capacity. This is the theoretical amount that can be produced by a machine or a piece of equipment or a factory over a period of time. From that are availability losses. So these are deducted from the overall loading time. This is unplanned working, not working times, setup and changeovers, breakdown failures. So a number of different things which are called availability losses, and that leaves total operating time. From that is we remove speed losses. So if you're talking about machines, this is when machines are idling, not working, not producing something for some reason. Maybe the operator's away, or maybe there's no components to go through the machine, or machines are running slowly. So we have speed losses. And then from that it's deducted, so that leaves net operating time, and from that it's deducted quality losses. That's when products are produced to an inadequate quality or an insufficient quality, the products are outside tolerances, or in some other way they're not produced to the right standards, and when those are removed we have valuable operating time. So we have a number of measures there: loading time, total operating time, net operating time, and valuable operating time. Okay, and these will enable us to work out three calculations. First one is the availability rate, which is a combination of total operating time divided by loading time. Then we have performance rate, which is net operating time divided by total operating time. And then finally we have valuable operating time, quality rate, which is valuable operating time divided by net operating time. When these are multiplied together, the results of these are multiplied together, this gives us a figure which we can call the overall ratio, which we can call the overall equipment effectiveness. How effective is our equipment in delivering whatever we're trying to deliver? Okay. In most operations you have what are called bottlenecks. So operations can have a number of activities in them, one linked to the other. One happens, the products in that one go to the next one, the products in that go to the next one. In this example we have three stages in the operation 1, 2 and 3, and at stage 1 the production is 200 units per hour. At stage 2 the production is 50 units per hour, and at stage 3 we're back to 200 units an hour. Okay, so stage 2, where production capacity is lower than at stage 1 and stage 3, is what's called a bottleneck. Production is produced and by stage 2, and stage 3, operation 3, will can process the 50 units per hour which are delivered to it by operation 2. That means we have 150 units per hour sitting idle, excess capacity. Meanwhile, in stage 1, operation 1, we're producing 200 units per hour, and the problem we have here is that operation 2 can only process 50 units per hour. So the excess production from stage 1 forms either inventory or queues, which need to be processed by stage 2. Okay, in the lecture I had a video clip which you can see grayed out at the bottom corner there, which talks about the relationship between layout and capacity. So I've talked about forecasts and how we use forecasts, and these are important to understanding and helping us plan our capacity. What we need to do here is forecast demand. So I'll go into forecast in detail, a little bit more detail in the next session, but at this stage let's just think about what forecasts can give us. They give us an understanding of demand. So here's the demand curve. It goes up and down as you see over a period of time. At certain points it'll be lower, and other points it'll be higher. And this is normal, a normal kind of experience of particularly consumer demand. So consumer demand might be seasonal, or it might change for other reasons. And what we're trying to do is understand demand uncertainty. How uncertain is that demand over a period of time? That's what's interesting to us, because this allows us to judge the risks of our measurement of capacity. So these little bow and arrows on this are actually, if you turn them on their side, will be normal distribution curves. So what we can measure is the variation around the demand curve in this particular situation. Does it go up and down by a great deal or by a small amount? And we can look at deciding how many degrees of freedom or how many standard deviations we will permit either side of the mean, and judge our capacity levels, or how much we need to deliver to meet demand, based on those distribution curves. Okay, so there's the demand curve again, and what we can do based on our measurement of demand is work out, in this example, what's the tolerance at the upper level and at the lower level, knowing that the likelihood of demand being above the upper level or lower level is only 5% in this particular instance. You might have a much tighter tolerance than that, or much looser tolerance than that. When demand and uncertainty is high, the risk to service levels under provision of capacity are also high. When demand uncertainty is low, then we are far more confident in our ability of our capacity to meet demand. So the shape of the of the distribution curve is important in understanding demand. So how can we reconcile capacity and demand? Well, we can cope with fluctuations in demand by absorbing demand, or adjusting what we produce to match demand, or changing demand itself. So there's three general approaches we can take. We can absorb demand, just say, well, we will produce things and hope that we can meet that demand. We can adjust what we produce to match demand, or we can change demand. The first one is level capacity, which is where we have a certain capacity and we just produce as much as we can to meet demand. The second example is called chase demand, and the third situation is called demand management. Okay, let's think about those visually. So here we have a demand curve, this time in red, and there's our capacity for a particular operation. This could be services or production, but more often than not will be a production situation. And in the example I gave earlier in the session, what we have is excess capacity at some points and insufficient capacity at other points. When we have times of excess to capacity, we can produce products for inventory, for stock, and then we can draw down on that inventory, that stock, when capacity is insufficient to meet demand. Chase demand is where there's our demand curve, where what we're trying to do here is adjust our capacity to match demand. so that it might be a lead or a lag. But if we understand what the demand curve is, then we can try to get our capacity to more closely match the demand curve. And we can plan for this in the future. If we have good forecasts, we can plan to change the capacity of our operations. This is much more commonly used in services where taking on staff and laying off staff is perhaps more easily done. With demand management, well, we have in the first two examples or situations, we have a certain demand curve. With demand management, what we try to do is reduce the volatility of that demand curve, reduce the peaks and reduce the troughs, and get the demand curve to be more closely match our capacity. Okay, so how might those happen in practice? Well, absorbing demand is keeping an output level. So we produce a certain amount, or possibly deliver a certain amount of services over a given period of time. We have excess capacity at some points, and at other points we have, and in that situation we will make to stock. So obviously with production you can make to stock. With services, much more problematic. You can't really store services in most cases. So what are you doing? You've just got idle capacity sitting around doing nothing. We can make the customer wait where demand is higher than capacity. With stock, we have parts which are finished goods, or customer inventory, a queue. Queues, backlogs also form. I came up with different examples for these. So what are factors, I said in the example of a lecture, which you're all familiar with, might affect an operation's ability to absorb demand? Well, in this situation we have a number of factors of capacity here. The room itself, and the lecturer at the front, and the facilities which are being used by the lecturer to talk about whatever subject he's discussing. Let's call it operations management. And the some of the factors here, well, it's the availability of the lecturer. It's about timetabling all those students to be able to be available at the same time as the lecturer, and the room availability in order to accommodate them in the lecture theatre. So this is a major problem for universities, having to deal with multiple timetables, limited space over a given working period of time. And I talked about the fact that in our university, one of the ways we've tried to accommodate that is to lengthen the working day. So our lecture theatres will be available at some points, other points they won't be available, but frequently throughout the day, if you go into any given lecture theatre, you'll find it's empty. It's empty because we can't actually schedule the lecturer and all the students who want to receive a lecture all at the same time. So you go in, you see empty rooms, empty lecture theatres, and then other times they're switching from one lecture to the next lecture to the next lecture in quick succession. Okay. With adjusting output to match demand, what we're doing here is dealing mainly with people. We might hire people and alternatively fire people when they're needed. We might take on temporary labour and alternatively lay people off. We might often get people to work overtime, or possibly short time. Overtime is a very, very common way of dealing with trying to match capacity to demand. And we might subcontract parts of the operations or get third parties to deliver work. Very commonly used as well. So in a services situation, this is very common to take on people when they're needed and lay them off or have them not working and not being paid, therefore, when they're not needed. In manufacturing, the way organisations overcome excess demand when they don't have stock of inventory is to get the factory to run over a longer period of time. So this is where shift patterns come into play. You have factories operating shift patterns in order to get the factory to work rather than just 7 or 8 hours or 10 hours a day or 12 hours a day, get it working 24 hours a day. Okay, here's a good example of where we have to match capacity to demand. There's only a certain period of time when these crops need to be picked, so all across the east part of England in particular, East Anglia and Lincolnshire, the vegetables and fruit are grown in great quantity and need to be harvested at certain periods of time, and organisations will provide labour, itinerant labour, to come in and harvest those for the farmers, and then they'll leave and do something else over the other period, over the rest of the year. Okay, so changing demand is about changing the pattern of demand. Developing alternative products and services. Maybe we can do that to shift demand to other parts of the organisation, to other parts of the operations. And here's an example of where demand might be managed. A card shop. What do we do with the card shop? Well, a card shop has traditional area points, birthdays obviously, Christmas, people want to buy cards. But when else? Well, Valentine's and those sort of periods of time. But also what you see is card manufacturers and card shops starting to try and develop demand, increase demand at other points in the year by Mother's Day, Father's Day, those sort of things, Easter cards I've seen. So all sorts of other situations where they're trying to create or generate demand for slack periods of time. Okay, capacity control, planning control is dynamic. Okay, so that's something I mentioned earlier in the session and I'll repeat here. So let's think about it as a process. We start with a time period. This is the previous time period to where we are now. We have an outcome, which was what was demand. We know what demand was because it happened. And we know what our capacity was because that was what that was. This leads to issues of costs. What were our costs? That was determined by our capacity, what we were producing, and revenues, what we received for the production, working capital we needed, customer satisfaction, was demand met, and so forth. The result of that could have been shortages or queues if there was excess demand, or inventory if there was excess capacity. With our knowledge of what happened in the previous time period, which could have been a year, or could have been a month, or could have been a week, or could have been a day, we can use that information to make decisions. Those decisions will affect our current capacity estimates in this new time period. Do we need to add units of capacity, people, machines, whatever, or do we need to remove them? And also, we can update our forecasts based on what happened in terms of demand from the previous period of time. So how much capacity, these will enable us to determine how much capacity we need for the next period. So we're looking at what our new estimates of capacity are and our new forecast for demand. We have a capacity level for this time period, and we have an outcome at the end of this time period. Exactly the same situation. What was actual demand and what was actual capacity? We will have known those because the time period will pass, and if we're measuring those, we will know what they are. Okay, and this would again give us costs, revenues, working capital, customer satisfaction, and so forth. And we will either have shortages and queues or excess inventory. And then next time period, we can then make a new decision. What's our new capacity estimate? What's our updated forecast? And we can make a decision about how much capacity we need for the next period. Okay, so for capacity and planning purposes, demand is normally considered as on a cumulative basis. So these curves I've shown you go up and down over a period of time, but normally for most situations we look at it over a period of time as a cumulative curve. And this allows us to alternate capacity and output plans and evaluate these for feasibility. So there's a demand curve, and as you can see in terms of demand, units of production are being forecast to increase over a period of time. That's what we can produce at average demand. That's our average demand. At some points, we're producing below our demand. Actual demand is below our forecasted demand. At other points of time, it's above. Right, I said earlier that I'd talk about queuing. Queuing is a particular situation. And what we have in queuing is often applied to services, literally physical queues of people, or it can also be applied to production. You can have queues forming in a factory where you have excess capacity at certain points and insufficient capacity or bottlenecks at other points in the factory. Here's a situation of a queue, and there you can see people arriving to be served in a particular operation. And what we can see here is that people are arriving at consistent periods of time. We have very little variability in arrival, so narrow distribution of process times for each person. In this next situation, you can see that people are arriving, and maybe the same number of people arriving, but the point is here that they are coming at less predictable periods of time. What we have is a wide distribution of processing times. In the first situation, where we have a narrow distribution of process times, capacity planning is very easy. In the second situation, it's much more difficult. Okay, so a queuing system can be seen as a boundary to the system. There's a boundary to the system. We have source of customers or demand, and then we have a series of servers. Server 1, server 2, and so on. You can think of many examples where you see this, where servers are dealing with customers in retail, in call centres, and all sorts of situations. We have a distribution of arrival times, which we can measure, and a distribution of process times. How long does it take for each person to be processed through the system? Here's one person waiting to be served, and a second person, and you can see a queue starting to form. A queue, or sometimes called a waiting line. Each person, as they arrive, can be seen by one or other server, and they get processed and served, and they leave the system. Now, people arrive, and the problem that organisations face is that if the queue is too long or the waiting time is perceived as too long, they will decide to renege, or sometimes it's called so another person's arrived there, or reject, or bulking at the length of time they anticipate waiting in the system. What can they do? They can go to another organisation to receive their whatever they're trying to receive. They can go to the shop at a different time. They can go to the restaurant at a different time. They can try the call centre at a different time, or they can find an alternative. Now, one of the key aspects underpinning queuing theory is Little's law. You can see there's the average number of customers in a stable system over some given time interval that is equal to the average arrival rate multiplied by the average time they are in the system, what we call the cycle time and the throughput time. This can be applied, as I say, to people arriving in a system or to production of products in a factory type system. Okay, now this formula, which is a very simple formula as you can see there, underpins almost all queuing situations. So often organisations will use quite complex algorithms to try and estimate the queuing time and manage their capacity against the demand they anticipate, and they'll use Little's law as the basis for doing that. Okay, I'll skip psychology of queues. So long-term facility capacity. I've talked at length about thinking about capacity and demand, and this is normally thought of on a fairly short-term basis. But from a more strategic point of view, capacity is also important. For example, you might be adding entire units of capacity, like factories or service facilities or shops, or you might be removing those units of capacity. So what we're trying to do is match our capacity with a strategy. We need to understand predicted demand, what our competitors are doing, are they expanding, are they contracting? We need to think about what our strategy is as a business, what we're trying to achieve. Are we trying to expand into new territories or develop new products and sell those? And to what extent are we internationalizing? Okay, this will lead to decisions about facilities. How much capacity do you want? What are our forecasts? Do you want to cushion against anticipated future demand? And do we want to develop economies of scale? So do we want to build up enormous levels of capacity in order to produce vast quantities which in turn, as we saw earlier, will mean we can shift into a mass production mode and reduce our cost per unit of production. We also need to understand when things are needed. So capacity and demand, we can either lead demand, in other words, anticipate demand, lag demand, in other words, demand happens and then we seek to ramp up or reduce capacity in response to changes in demand, or we can try to match demand. What we're also interested in is where we're going to locate. Are we going to locate our operations where demand is, or are we going to locate our operations in a maybe cheaper location elsewhere, and then bring the products or services to the customer, or bring the customers to the products and services? In terms of aggregate planning, and in summary, what we have is a forecast. This leads to an aggregate plan, which is a function of our people, warehouse space, if we're producing products to store, materials we need, money we need to invest in capacity. And this will lead to a strategy, or be part of a strategy. Are we going to modify our supply, which you can see is either chase demand, level capacity, or a mixed plan of some sort, or are we going to try and manage demand? The reality for most organisations is they do a mixture of all these. This will lead in turn to what we call a master production schedule, which, when I come to talk about inventory, we will understand underpins most production plans for manufacturing organisations. So, going back to those questions, you need to understand what we mean by capacity management. Think a little bit about demand and capacity measurement. What are the different ways of coping with demand fluctuation? We talked about that. How can operations plan their capacity levels? So, in terms of changes in demand, how can operations think about how they will adjust their capacity to match that demand, or will they bother doing that? Maybe they'll alter demand to bring that closer to capacity. I talked about queuing theory, which is commonly used in service situations. And then the next session will be looking at managing flow. By that, principally I mean inventory. I'll look at forecasting, inventory, touch on something called ERP, Enterprise Resource Planning, and touch on lean production and lean synchronization. And those are the chapters which relate to managing flow. Thank you very much.